All right, so what was happening in Advent Code Day 23? We had this network of ENCODE computers, 50 computers, and they're all running this copy of the same program. They all get separate inputs to start, and then they send these packets, which are 3 values, destination X and Y. And we're supposed to sort of run them all in parallel until we get a packet sent to 255. So how are we going to code that up? So I have my encode stuff. That's at the top. Hasn't really changed. Then I'm going to, make 50 input queues, and then each program just gets its own separate queue, basically, and the problem says to return -1 if there's no packets waiting. Then we create our 50 computers. And for part 1, we just need this stuff. So, run each program sort of in turn, get an address X and Y from a packet. If the address is 255, then we're done with part 1, right? Just print out Y. Otherwise, add X and Y to the input queue of whatever's getting sent the message. So this required a little bit of change in my encode interpreter, which is I added an optional timeout to run. So the idea, before I had this run function, just ran until it produced some output. But in this case, we need to run all of the computers in parallel. So it's not good enough to, right, if you just run until there's output, then it just blocks forever. Because program 1 is waiting on program 6 to send it something like that. I don't know the specific numbers. So anyway, I added a timeout and kept track of how many steps it's been running. And just if it's been running, timeout number of steps, then return none. So I use this in case it's not ready to send a packet yet. Notice that I do use the blocking runs for X and Y, since I assume that if it starts sending a packet, it wants to finish sending that packet, or it's ready to finish sending that packet, which ends up being true. So that's pretty much it for part 1. And for part 2, we actually do something with the 255 packets. So we send it to, well, whatever. It gets stored. We have a single slot, basically, for a packet, which is what we're calling NAT. Right, it only remembers the last packet. And if the network is idle, then the NAT will send the last packet to address 0. And we want to know what the first packet, as the NAT sends some packet to address 0, and then it keeps running the network. Eventually, the problem statement tells us the NAT will deliver the same Y value twice in a row to computer 0, and we want to figure out what that is. So what is the change here? I'm going to keep track of the NAT packet and also the last NAT packet, and also when the last packet was sent and how many time steps we've gone through. So this is going to be our idleness detector. So if it's been 500 timestamps without a packet, that's my definition of idle. Then add the NAT packet to Q0. And if we have sent a NAT packet before and the Y value is the same, then we're done. So just print out the answer. And otherwise, just record, the packet, the Y value that we sent. And also record that this counts as a change, right? Give the network some time to settle down before we declare it's idle again. Let's just increment T, and then also whenever we send a packet, we need to update the change field. So yeah, that's pretty much it. Parts 1 and 2. It's a pretty quick day today. Well, my program speaks soon. I told it to print out all the packets, so that's maybe not helpful. I'm still kind of curious what it's actually computing, but I won't try and solve that right now. So yeah, that's it for day 23.